Hello everyone, I'm Mansha Soni and welcome to my virtual poster. I'm working as a PhD student in Schulz Lab at Ruhr University Bochum in Germany, and the title for my poster is Biomarker Identification for Depressive Disorders via Untargeted Metabolomics. So starting with the introduction, as we all know that depression is a neuropsychiatric disease which is associated with high levels of mortality and morbidity. But why is there a need to develop biomarkers for depression? So the answer to that question lies in the fact that despite being a disease with such increasing number of incidences, there is still a shortfall of efficient diagnostic tools. So for example, I have shown here some tests for depression which are largely based on interviews and questionnaires, which may often lead to misguided results. And moreover, the existing biomarkers also faces some issues with specificity, reproducibility, and sensitivity, which limits their uses in clinical practices. Therefore, in order to address all these limitations, we have introduced an untargeted metabolomic workflow for discovering the potential biomarkers in human serum samples for depression. So for the success of any metabolomic study, a good experimental design is a most important step. So starting with the sample preparation, our extraction protocol is largely based on the differential polarity of metabolites, where we use different solvents like MTBE, ethyl acetate, water, methanol, just to ensure the extensive coverage of the metabolites. And then comes the data acquisition step, where we have employed high performance liquid chromatography coupled with SEQTOF. And then comes the processing and statistical analysis steps, which is carried out using different softwares like Enzymine and MetaboAnalyst. And then finally, the structural annotation is conducted using Sirius and GNPS. So now moving on to the measurements and processing part. So these two images just shows the base peak chromatogram of lipids on a C8 column and polar metabolites on a helic amide column. So now this raw data is subsequently exported to Enzymine, where after performing different steps, processing steps like mass detection, chromatogram builder, and many other steps, we get a feature table out of this raw data. So after careful extraction, processing, and analysis of a subset of human serum samples, we were able to identify 4,000 plus features with MS-MS fragmentation pattern across all the polarity segments, which will further enhance our capacity for biomarker identification for our future experiments. And additionally, we also want to see whether the LC and the MS methods are reproducible or not. So in order to check the technical reproducibility, we plotted the PCA plots, and here it is shown by the tight clustering of the blanks and quality control samples that there was very low technical variances, indicating high technical reproducibility. And finally, we also wanted to see whether the annotations that we get are actually reliable, or do they make any sense or not. So we exported the feature list from Enzymine to different softwares like GNPS and Sirius, and there we found a diverse array of compounds belonging both to the polar fraction as well as to the non-polar fraction of the human metabolome, indicating reliable results. So on a concluding note, I would like to say that our developed protocol can manage to overcome the limitations of the existing studies, which focus only on the lipid metabolome and utilizes the small sample sizes. And currently we are also applying this protocol to 160 clinical human serum samples of controls as well as patients to hopefully find a new biomarker for depression in future. So thank you all for your attention and see you soon at the conference. Bye-bye.